Solve the system of equations by graphing. Check your solution algebraically. So let's graph each of these. So let's start. Let me find a nice dark color to graph these with. So let me graph this top equation in blue, this parabola. So the first thing to think about is this going to be an upward opening? Well, one, how did I know it's a parabola? And that's because it's a quadratic function. We have an x squared term. We have a second degree term here. And then we have to think about, is it going to be an upward opening or downward opening parabola? And you see it's a negative coefficient in front of the x squared. So it's going to be a downward opening parabola. And what is going to be its maximum point? Let's think about that for a second. So this whole term right here, is always going to be negative. So its maximum, or it's always going to be non-positive. X squared will be non-negative. When you multiply it by a negative, it's going to be non-positive. So the highest value that this thing can take on is when x is going to be equal to 0. So the vertex of this parabola is when x is equal to 0 and y is equal to 6. So x is equal to 0 and y is 1, 2, 3, 4, 5, 6. So that right there is the highest point of our parabola. And then if we want, we can graph a couple of other points just to see what happens. So let's see what happens when let's say x is equal to, so let me just draw a little table here. So when x is equal to 2, what is y? So negative x squared plus 6. So when x is 2, what is y? You have 2 squared, which is 4, but you have negative 2 squared. So it's negative 4 plus 6, it is equal to 2. And the same thing when x is negative 2, because you put negative 2 there, you square it. Then you have positive 4, but you have a negative there. So it's negative 4 plus 6 is 2. So you have both of those points there. So 2 comma 2. So 2 comma 2. And then you have negative 2 comma 2. Negative 2 comma 2. And then if I were to graph it, I could even do let's try it with 3 as well. So if we put a 3 there, 3 squared is 9. Then it becomes a negative 9 plus 3 becomes negative 3. And negative 3 will also become a negative 3. Right? Negative 3 squared is positive 9. You have a negative out front. It becomes negative 9 plus 6 is negative 3. So you have negative 3, negative 3. And then you have 3, negative 3. So those are all good points. And now we can graph our parabola. Our parabola will look something. Oh, I was doing well until that second part. Let's see. Our parabola will look something like that. Let me just do the second part. That second part's hard to draw. Something. Parabola, almost. Let me do it from here. Almost. It looks something like that. There. Well, no. Let me connect this dot right here, and then let me connect this. So it looks something like that. That's what our parabola looks like, and obviously it keeps going down in that direction. So that's that first graph. Now let's graph this second one over here. Y is equal to negative 2x minus 2. This is just going to be a line. It's a linear equation. The highest degree here is 1. So our y-intercept is negative 2. So 0, 1, 2. Our y-intercept is negative 2. And our slope is negative 2. So if we move 1 in the x direction, we're going to go 2 in the y direction. If we move 2 in the x direction, we're going to move down 4 in the y direction. We're going to move down 4. If we move back 2, we're going to move up 2 in the y direction. And it looks like we found one of our points of intersection. And let's just draw that line. So that line will look something like, it's hard for my hand to draw on that. Let me try as best as I can. So it will go something. My hand is having my tablet. This is the hardest part. It will look something like that right there. And so the question is, where do they intersect? Well, one point of intersection does immediately pop out at us. They ask us to do it graphically. That point right there, which is the point negative 2, 2, which is the point negative 2, 2, seems to pop out of. So this is the point negative 2, 2. And let's see if that makes sense. When you have the point negative 2, well, when you put x is equal to negative 2 here, negative 2 times negative 2 is 4, minus 2, y is equal to 2. When you put negative 2 here, y is also equal to 2. So that makes sense. And then there's going to be some other point way out here where they also intersect. There's also going to be some other point way out here if we keep making this parabola. Let's see. When y is equal to positive 4, then you have negative 16 plus 6, you get negative 10. So positive 1, 2, 3, 4, and then you go down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks like that might be our other point of intersection. So let me connect this right there. And then our other point of intersection looks to be right there. If we just follow this red line, it looks like we intersect there. And let's verify that it works out. So 4, -10, we know that that's on this blue line. Let's see if it's on this other line. So -2 times 4 minus 2, that is -8 minus 2, which is equal to -10. So the point 4, -10 is on both of them. When x is equal to 4, y is -10 for both equations here. So they both definitely work out.